Hello everyone, let us start with our question. In this question, what is given? That it is given that two parallel wires in the plane of the paper are at a distance x0 apart. Now a point charge is moving with a speed u between the wire in the same plane at a distance x1 from one of the wire. So first of all, we just represent this with a situation. So this is one of the wire and this is another wire. So basically these are the parallel wires, okay? And there is a charge which is moving between these two. So let's say this is moving like this, and let's assume that this distance is, let's say this is x1 and total distance is given as to be x0. So this distance would be x0 minus x1. Okay. Now else what is given? When the current, when wire carries the current of magnitude I in the same direction, radius of curvature is given as to be r1. Now if the current direction in the two wire are different, that means opposite, so radius of curvature is r2. If x0 by x1 is given as to be 3, we need to find the value of r1 by r2. Okay, so in one situation, so the current is in the same direction, and in the other situation current is in the other direction. Now what is happening? So they are moving in a this circular path. Okay, and the radius of curvature is given as to be r. So in a magnetic field, what is the radius of curvature for a charged particle? R value is equals to mv by, this value is equals to mv divided by qb. This is the value. So from here what we can see, that because the value of the magnet, this velocity would be same, m and q are already same for the charged particle, so we can say that r is inversely proportional to b. Okay, or we can say that our r2 by r1 or r1 by r2, this would be equals to what? So because this is the inverse relation, so it would be b1 by b2 by b1. Okay, b2. Now in the b2, what is happening, that direction of the current is opposite. Okay, here the direction of current is like this, here the direction of current is like this. So what will happen into this situation? The magnetic field would be b2 would be equals to magnetic field due to left plus magnetic field due to right. Okay, the direction of the magnetic field would be the same, okay, when the direction of the current is opposite. So for example, here it is upward, here it is downward, so magnetic field would be downward into the plane of the paper. Okay, so what would be the value? So we know that value for magnetic field is given as to be, for a straight current carrying conductor, its value is given as to be mu naught divided by 2 pi, mu naught I divided by 2 pi, and the distance for left is this x1. So we write the distance as x1 plus mu naught I by 2 pi. From the right it is x0 minus x1. So this is the value of b2. Similarly, b1 value would be what? So in the b1 case, the direction of current is same, so this would be the difference. So we just take the difference because the magnetic field would be in the opposite direction. So 2 pi x1 minus mu naught I divided by 2 pi x0 minus x1. Now if we take the ratios of these two quantity r1 by r2, it would be equals to b2 by b1. So we can take the ratio. So what we can see that mu naught I divided by 2 pi, so we can take it to be common, and when we are taking the ratio, so this term, constant term, would be cancelled. So we can just write our r1 by r2 as r1 divided by r2 would be just what? It would be equals to 1 over x1 plus 1 over x0 minus x1, this term, and then divide by, sorry, we just rewrite this division sign, divided by 1 by x1 minus 1 divided by x0 minus of x1. Okay, now in the numerator, if we take the LCM, so what will happen? So it would be x0 minus x1 plus x1. Okay, like this. Now the LCM of the numerator and the denominator would be same, so we can cancel, and we can just write the numerator of the denominator. So it would be x0 minus x1, okay, minus x1. So the LCM would be cancelled, so it would be x1 x0 minus x1. Here it would be x1 x0 minus x1. We can cancel these values. So then our r1 divided by r2, this would turn out to be, so here x1 and x1 would be cancelled, so it would be x0 over x0 minus 2 times x1. Now if we divide the numerator and denominator by x1, so what will happen? So it would be x0 by x1 divided by, here it would be x0 by x1 minus, when we divide this term, so x1 would be cancelled, so it would be just 2. Now this value has given as to be 3, so we can say that 3 divided by 3 minus 2. So r1 by r2 would turn out to be 3. So this is the final value. We need to find the ratio of r1 by r2. So r1 by r2 we just write. So this value is equals to 3. So hope you have understood the solution. Thank you.
Hello, we are given the question, and the question says the wire loop PQRSP, so this is PQRSP again, by joining two semicircular wires of radius R1 and R2, carries a current I as shown. The magnitude of the magnetic induction at center C is what? So we have to find the magnetic field, right? Magnetic induction, right? So magnetic induction for the circular coil, right? So that would be like at center. So that would be equal to mu naught In by 2R. That is for the center, right? So due to this first wire, for since this is a semicircular coil, right? So N would be equal to 0.5. This is not a complete loop, right? So magnetic field at C due to first coil, right, would be, since the current is going in the direction, we can find using right hand thumb rule or the screw rule that the magnetic field at C would be out of the paper, right? So that is equal to mu naught I into 0.5 by 2R1. So that would be equal to mu naught I by 4R1, right? Out of the paper, that means we can write it to be positive K. Now, due to second coil, we can write B2 to be equal to, since the direction is opposite in the direction of the this current, right? So magnetic field would be inside the paper according to the screw rule. So that would be equal to mu naught I into 0.5 by 2R2. So this turns out to be equal to mu naught I by 4R2 along minus K direction. Right? We can assume that that is K direction. So they would be in opposite direction. B at center would be equal to B1 minus B2. So that turns out to be equal to mu naught I by 4 in bracket 1 by R1 minus 1 by R2 along K. Right? So this would be the magnetic field. And this direction represents the net magnetic field would be out of the paper. Thank you.
Hi everyone, so we are given with the question which says a pair of stationary and infinitely long bent wire is placed in the xy plane as shown in the figure. The wire carries current of 10 ampere each as shown. The segment L and M are along the x-axis. The segment P and Q are parallel to y-axis such that the distance between OS and OR is given as 0.02 meter. We need to find the magnitude and direction of magnetic induction at origin O at this point. Alright, so here we can see in the diagram uh, there are two pair of bend wire that has been given, that is LP and MQ. So here we can see M and L are lying along the x-axis. So we can see a magnetic field due to section, or we can say due to wire L and M will not be taken, or we can say will not constitute to magnetic field. So here let's write it more properly over here. Constitute to magnetic induction at O. As we know, a magnetic field will be around the wire carrying current, alright, and not on the axis, we can say. So here we can see the wire M and L is lying along the point where we are interested in finding the magnetic induction. So L and M will not constitute for magnetic induction at O. Therefore, we can write net magnetic field at O can be written as, therefore we can say net magnetic field will be due to wire uh, P plus magnetic field due to wire Q. Alright, so let's try to calculate the magnetic field due to these two wires. So we know these are the semi-infinite wire, as we can see it over here. From S to here it is, we have to consider from S to infinity, and from here R to infinity. That is, in this case we can consider it to be a semi-infinite wire. So for semi-infinite wire we can directly use the results. So for P we can write first. For semi-infinite, result is mu naught I by 4 pi A. A is the distance, here is OR. Alright, from the point where we are interested in finding, that is OR. So this is the magnitude of the magnetic field we are getting, and if we wish to find the direction, so for direction can be given by right hand thumb rule. Thumb should point in the direction of current, that is downward, and curling the finger around this, so finger that is, it will come outside. The magnetic field direction will be outside, or we can say represent it with a dot. So this is how the magnetic field due to wire B we have calculated. Or if we simplify it further, so we can write mu naught by 4 pi can be taken as 10 raised to minus 7 into I is been given as 10, dividing it by OR. OR has been given as 0.02, and this comes out to be 10 raised to 5 into 10 raised to minus 5, uh, and direction is outward. Alright, so this is what the uh, magnetic field due to wire P we are getting. Similar way we will calculate it for BQ. As we can see, the wire is carrying the same current, and it is also semi-infinite in length, so we can write this can be written as I am directly writing the result over here. So this also will comes out to be 5 into 10 raised to minus 5, and the direction can be again calculated by using right hand thumb rule. So again it will be outward at point O. Alright, so from here we can say, therefore BO, that is net magnetic field at O, can be written as BP, that is this can be written as 2 into 5 into 10 raised to minus 5, and it is outward. So this gives us the answer as 1 into 10 raised to minus 4 Tesla. So this is the unit of magnetic field. So we can say this is the answer to this question, that is net magnetic field or induction at O we are getting. So I hope you have understood the concept well, and thank you for watching.